Hey guys, I hope that I'm live right now. If you guys are able to listen me properly, as well as there's no issues with the audio or the video, please let me know. Hello everyone, I hope that I'm live right now, guys. If you guys are able to listen me properly, as well as there's no issues with the audio or the video, please let me know. Everything is okay, no issues with the audio or the video, right, guys? Okay, great. So, how are you guys? Fine, good, great, amazing. What is the scenario? How are you guys? Is everybody fine? Good, great, amazing. What is the scenario, guys? Fine? Good? Wonderful. Great, guys. Awesome. Awesome. So, now that we have a good understanding about how you guys are, let's talk about what we are going to do in our today's class, guys. Okay. So, today is going to be a short class because I have some work. We are going to look at the data set that we are going to work on. Okay. So, we are going to start with our project, right? So what we're going to do is we're going to look at the data set that we're going to work on and what are the different things that we need to understand. And from there, we'll be proceeding further. Okay. Yeah, today we are going to start with our project, guys. Okay, so let me share my screen first of all with you guys. Okay, the screen has been shared. Let me open up the data set. Calophy. Calcofi, I'm so sorry, Calcofi, dataset, Kaggle. So this is the dataset that we are going to work further with, guys. Okay, this is an oceanic dataset. Okay, so basically it represents a dataset that has been collected from 1949 up till this particular point of time. That means this dataset is basically a accumulation of more than 75 years of work. More than 75 years of work, guys. And it is basically oceanographic and larval fish dataset in the entire world. Like, it is the most biggest dataset in the entire world, right? It provides you the data of over 250 different species of fish. Okay, and the larval, basically the frequency, egg abundance, and all these kind of stuff. In simple manners, if I tell you guys about it, so basically if a particular fish has been born, what was the amount of salt that was there in that water, what was the temperature of that water, where was that particular fish born at any particular point of time. Okay, what was the silicate, phosphate, oxygen ratio in the water at that point of time, and so on and so forth. Now the data set that we are able to see right over here, it will only be contained towards 500 meters of depth within the ocean. So that is the data set that we are having right over here. As you're able to see, this is how these are the columns of the data set itself. Okay, that you will be able to see right over here. There are 10 out of 74 columns. Let us see the columns itself. So these are the different columns that are there. Okay, these are the different columns that are there right over here. What was the depth in meters? What is the temperature in degrees Celsius? The salinity of the water itself, oxygen levels that was there, and so on and so forth. Okay, so this is what we are going to use for our data set as well, guys. Are you guys able to understand this? Please let me know. Are you guys able to understand what data set are we going to use, guys? Please let me know. We are going to try to find a correlation between the salinity of a water, that is how much salt is present in the water, and what is the temperature of the ocean water. That is the kind of relationship we'll try to find using this particular dataset. Although this dataset contains a lot of different things, we are not here to talk about every single thing itself. Our aim is to find a correlation between the salinity of the water, that is how much salt is present in the water, and what is the temperature of the water at that point of time. We're going to create a model that is able to predict this. Okay, are you guys able to understand this? Please let me know. So we'll feed in the salinity of the water, that is how much salt was present in the water, into the model, and will predict for us what will be the desired temperature of the water itself. And all this is not for your normal water. Okay, don't feel like, okay, I will take some water and mix some salt within it and that would be the temperature of the water. This is for oceanic data. Okay, so ocean based data, we'll be trying to create a particular model to predict that. Now, where can this be used actually? For example, in cases where you're breeding, let's say different kinds of fishes, right? So fishes require a particular level of salinity, a particular level of temperature, and using this particular data set, you can figure out which particular part of the entire world this particular fish can be found at. Okay, wherever there is the salinity that and temperature that matches this particular readings, we can find the particular fishes to be at that particular point. Okay, so that is what our aim will be. This is a new data set that is there. So like this is not something that is common. So I thought of using something that is a little bit outside the box. People will be using the same data sets like predicting the house prices and everything. So I wanted to use something that is a little bit different so that you guys are not making the same project every single place, right? Okay, so we can download the data set from right over here. Okay, you can just click on download from right over here. It will download the data set for you. As you're able to see, the data set, I think so, has been downloaded. Okay, I think so. I think so. I will have to sign in with Google first to download the data set itself. Continue. Then maybe I'm able to download it. Yeah. So you will have to sign in before you are able to download it, guys. Just do remember that. Okay. I made that mistake right over here. So you will have to sign in into Kaggle. For all those who wants to build a career in data science, for all those who want to build a career in machine learning, artificial intelligence, Kaggle is one of the best places to practice. Kaggle is one of the best places to learn. And actually, if you are interested to actually get a job inside of data science or machine learning, if you are having an awesome Kaggle profile, I've seen people just getting placed due to their Kaggle profile itself. Companies will start approaching you. So Kaggle is actually a pretty great place to practice and learn from. That will be something that I will definitely suggest you guys at. Okay, Kaggle. That is the website that I'm currently at. Okay, Kaggle. One of the best websites out there that you guys can work on. Okay, again, this is a free website. A very good support system is there. Great people are using this Kaggle website itself. And so every time that you're having any doubts or queries, you guys can actually enter into the discussion modes and you can like go over some of the discussions that is there. There are some kind of competitions that happen. So to make sure that you guys are actually utilizing Kaggle well, you have to give these active competitions itself. And you can earn a lot of money as well if you win these competitions. Like the prizes, as you're able to see, are millions of dollars in prizes. $1 million, this is, I think so, $1 lakh, $1 lakh, $50,000, $50,000, a lot of like it continuously goes on. There are many that is going on just for knowledge as well, so you can definitely take part in them as well. So if you guys are able, and don't do shit things like this, that is the reason why I didn't do it. Okay, do not go for a Titanic data set and house pricing data set and voila, I've done everything. Okay, that does not work like that. They're just for knowledge, they're just for practice itself. Main is to participate in these upcoming competitions that are there and building your profile from right over here. Many people I've seen participating in these competitions, winning lakhs and lakhs of rupees, and also getting placed from right over there as well. You guys can formulate team within people who are having a similar mindset on Kaggle. If you don't know machine learning properly, you don't know deep learning properly, you can go into the learning aspect of Kaggle as well. You guys can learn everything from right over here. Although we are also creating something very similar to that, but in video format. But yeah, this is a great place to learn from as well. For example, if I want to learn data visualization, right, it has a great place to learn from. It has exercises and everything to do as well. So I'll definitely suggest you guys to explore this a bit. Okay, again, my job is to tell you guys about the things that are there in the industry and how to leverage that for your own benefit as well. Except that if you want to do it, it's for you. If you don't want to do it, it's for you, as it's not for you. Like you guys can decide that, right? Okay. Free or paid competition. Kaggle is a free platform, guys. Like Kaggle is like how can I explain it to you guys? Kaggle is like Reddit. Okay, Kaggle is like something like Instagram. Okay, so Instagram is free, right? There's nothing to be paid for by Instagram, right? So you guys can definitely do that. Do the winners of Kaggle competition get awards? They get the money, a lot of money, as well as job opportunities. So I've never won any Kaggle competitions. I was never good at it. But one of my friends, he actually participated in it, and I think so. He earned somewhere around 32 lakh rupees in that competition. He was two people, two of them together won, I think so, 74 lakh rupees in that competition, and he got 32 lakhs out of it. So along with that, he got a remote work from home job by a company from Singapore. And I think so he was earning at that point of time, it was 3 years ago, so I think so he got an like a base package of $1 lakh, like that was around 75 lakh 75 nahi, 65 lakhs or 75 lakhs approximately base in hand remote work from home for a company from Singapore, just by winning that competition. So yeah, if you are doing well right over here, there is a lot of money to be made out of it as well. But again, it's not for everybody. Not everybody makes money out of it. Most of the people use Kaggle for the purpose of studying, for the purpose of improving their machine learning aspects itself. And you get to learn a lot. You get to learn a lot by participating in these competitions. The highest that I've ranked ever in my entire life on Kaggle was 150 in the entire world. So I'm not that good at Kaggle. Like I gave a lot of different competitions. The highest that I was able to rank was 150, 152, 153. I don't remember that. So yeah, is data visualization a part of data science? Absolutely yes. Absolutely. Anything that has data in front of it, it's a part of data science. Think about it in such a way. Okay. So let's get started, guys. Let's keep that up. We'll use Colab itself. We'll use Colab for our purpose. You guys can use Kaggle as well for the same, but I am pretty done easy with Colab. So I'm going to use Colab right over here. Now we'll connect Colab to the backend. So that is like we'll get the resources that we need to code on. Once we're able to do this, it will just take a minute or two. Yeah, we are having done this. We are getting somewhere around 12 gigs of RAM, 12 to 13 gigs of RAM, as well as somewhere around 100 gigs of storage as well. So what we're going to do right now is that we are going to upload our files. Okay, upload the sample, upload the data that we want to use, right? So for that, what I'm going to do is I've downloaded the data set from Kaggle. So if you see in my downloads, I've already downloaded. I'm going to unzip it here. Okay, I'm going to unzip it here. Open. I just require the bottle.csv. I don't require everything. Okay, so I'm going to just click bottle.csv. That is the dataset that I require, and I'm going to extract it to our downloads. Okay, so I'm just going to go on downloads and extract it right over there. So this is the dataset that we're going to use, guys. Where is the dataset? I extracted it. Where did it go? Did I not extract it? What the fuck? Okay, let me extract it once again. So I'll extract it to desktop. Okay, let's extract it to desktop itself. Okay, so that should have been extracted right over there in the desktop. Let me check it right over here, desktop and bottle.csv. So this is the dataset that I've already like downloaded and extracted. I'm going to upload it to Colab. So let's do that right over here. So I'm just going to click on this upload to session storage, and I'm going to upload my data set right over there. So that is present in the desktop. Where did it go? Dude, either I am getting old or my eyes are shit right now. I'm not able to see the data set once again. Let me do B. Yeah, I got it. So open and ensure that your files are saved elsewhere. The runtime files will be deleted when the runtime is terminated. हाँ भाई समझा. So as you're able to see, the bottle.csv is getting uploaded. Okay, it should be uploaded right over there. So yeah, as you're able to see, the bottle.csv is now available for us to use. Are you guys able to see this? I just clicked on the refresh button after the upload was complete, and you are able to see that the upload has been completed and bottle.csv is present on our screens right now. Now I'm going to click on these three buttons, and from there I'm going to click on copy path. Okay, because right now the bottle.csv that I've uploaded, I don't know where it is present in Colab, right? Colab is not on my computer. Colab is just a website. The bottle.csv actually getting stored on some computer at Google. I don't know exactly where bottle.csv is. So I'm just going to click on copy path, guys, so that I have the path to that particular file that I want at a later point of time. And that's it, guys. That's it. You are ready to start code. Okay, you are ready to start coding, guys. Okay, so shall we start with our particular code, guys? Please let me know. Shall we start with our coding, guys? Please let me know. Yes, no, what is the scenario, guys? Yes, shall we start? Okay, great, guys. Awesome. So first we need to get some help. Okay, Python can do everything on its own. Okay, it's basically like you saying I want to build Burj Khalifa. Okay, I want to build Burj Al Khalifa itself with just a hammer and a chisel. That's it. Like, it might be possible, it might take you thousands of years to build the entirety of Burj Khalifa, but just by a hammer and chisel it is going to take up a lot of time. So we need some help. We need cranes, we need bulldozers, we need cements, we need iron, we need a lot of different things. Okay, so we need to get some help for Python as well. Python can do everything on its own, but Python has some of these different libraries that exist that helps Python do some stuff much more easily and much more faster as well. Now, some of these libraries that we're going to use, the first library is import. Okay, this is how you get these libraries. Okay, this is how you get these libraries, guys. You're going to import NumPy as the first particular library. Now, NumPy is a particular library that helps Python deal with matrix-based calculations. You have learned about matrix multiplication, right? Matrix addition itself when you were in 10th standard, I guess, 10th or 11th standard in maths. Matrix, 2D matrix, 3D matrix, 1D matrix, matrix multiplications and all these kind of stuff, right? So matrix multiplication is pretty complicated, especially when you are having like millions and millions of rows and thousands of columns. It can get pretty like darn complicated for you guys. So to handle such type of big particular matrix related problems, you're having a library called as NumPy that we are going to use. Now again and again, whenever I want to use the library, I will have to call NumPy, like, NumPy, please come and help me. Now NumPy is a big word. I don't want to write it again and again. So I'm going to give it a nickname. From today onwards, I'm going to call NumPy as NP. Okay, from today onwards, I'm going to call NumPy as NP. That is NumPy's nickname from today onwards. So instead of writing NumPy again and again, I can just refer to it as NP. Okay, I can just refer to it as NP, guys. The next particular library that we are going to import, right, is the pandas library. Now the pandas library is built to basically handle working with datasets. All these datasets that are there, right? Big datasets that are there. How to access its columns, how to access its rows, how to like change some of the things. So anything related to datasets, if you want to handle, which are called as data frames, you convert the datasets into something called as data frames. That is what pandas will help you manipulate. Pandas will help you play around with these data sets very easily. Again, we are going to give it a nickname as well, that is called as PD, guys. Okay, we're going to call it as PD right over there. The next particular data set, next particular two libraries that we are going to import are going to be your Seaborn and Matplotlib. Now, Seaborn and Matplotlib are data visualization libraries. These help you to create graphs for your users or for yourself or for understanding the data itself. You can create graphs or anything like line graph, bar graph, histograms, pie charts, right? All these different charts that you have studied in your childhood. Basically, these libraries, that is Seaborn and Matplotlib, help you build those. Now, why? Let's first write the code and then I'll explain why do we need two libraries for that. Why not can we work with just a single library as well? So import, I'm sorry, SEA. Why is the autocorrect not working? SEABORN, Seaborn as SNS. Okay, so you again give it a particular nickname as SNS itself. How many of you guys know what is Seaborn and what is Matplotlib, guys? Please let me know. How many of you guys already know what is Seaborn and what is Matplotlib, guys? Can somebody let me know? How many of you guys know Matplotlib and Seaborn? So for those who already know what is Matplotlib and Seaborn, those who don't know, it's fine. Okay, I'm going to explain it to you guys. You don't have to worry about it. Okay, this is not, I'm like I said, no prerequisites. I'm going to explain it to you. But for those who already know, I want to understand from you guys, what do you think is the difference between Seaborn and Matplotlib? What is the difference between Seaborn and Matplotlib, guys? Please let me know. Don't worry, I am going to explain it. Okay, I'm just like, for those who already know that, I want to understand from you guys. Like, see, this is a very common interview question. If you are working in machine learning or deep learning or data science, you are going to use Seaborn and Matplotlib. And if you don't understand the difference between these two libraries, then yeah, there is something very fucked up with you. Okay. So those nicknames are predefined, or we can choose anything. You can name it as Shaurya as well. Call NumPy as Shaurya. It's up to you guys. It does not matter. Okay. Okay, Matplotlib is for plotting graphs. Seaborn is for ML. Absolutely wrong. Seaborn is a library for making statistical graphs in Python. That is the definition. I'm not asking that. Seaborn is normal, but Matplotlib is the advanced version of Seaborn. Very good. Okay, so let's try to understand this. Both Seaborn as well as Matplotlib help you create plots, help you create graphs, help you create charts. Both of them do the exact same thing. But why do we require both of them? Why do they even exist? If both of them are doing the exact same thing of creating graphs, why do we need two different libraries out there? The reason for that is actually pretty simple. Think about it in such a way. Seaborn is like taking a flight, okay, or taking a particular car to go from point A to point B, or taking an electric cycle. Okay, taking up an electric cycle, the most easiest, right? Nothing to even learn right over there. You sit on a cycle, you press like the gear and it will take you to wherever you want to go. Right? Simple, sweet. It can take you to point A to point B very easily, right? Nothing too complicated about it. Matplotlib is like you flying a fighter jet. There are millions of things that you can do. Even if you want to go 10 kilometers as well, or even 1 kilometer, you can take a fighter jet and go. You can take a fighter jet and go as well. But again, you will have to drive it. There are so many buttons. There are so many different things that you can do with a fighter jet. You can take up a spiral and then go on the fighter jet itself. You can fly the fighter jet and then land it after 1 kilometer. You can just not fly it. Just drive through the entire way of 1 kilometer itself to reach your own spot. The difference between the two is that your cycle was easy to use. You want to go from point A to point B, you have to do a very simple thing. You don't need a fighter jet to do that. Right? You need a normal thing, okay, not too complicated, simple. This is what I want, just feed it, it will do that for you. But you can't do complicated stuff with that cycle. You cannot make that cycle fly. You cannot take that cycle and travel 3000 kilometers itself. You cannot do that. Very complicated stuff. That is where you require something like a fighter jet. That is where you require something like Matplotlib. Matplotlib gives you multiple features, multiple customizability. You can change anything that you want to do. Seaborn doesn't give you that flexibility. It is simple, it is easy to use for basic purposes itself. But if you want to create something that is more robust in nature, you have Matplotlib with you. Are you guys able to understand the difference between Seaborn and Matplotlib? Please let me know. Are you guys able to understand the difference between Seaborn and Matplotlib, guys? Please let me know. Yes, everybody is able to understand this. Great, awesome. Now, while importing Matplotlib, I have imported something called as PyPlot. What is this? Like, Okay, I'm able to understand that I'm importing matplotlib, but what is this pyplot along with that? So pyplot is a sub module of matplotlib. So matplotlib is a library. A library has multiple different sections. When you go into a library for reading books, right, there will be one section dedicated to just fiction, there will be one section dedicated to just non-fiction, there will be one section dedicated to Jeronimo Stilton or something like that. Like multiple sections are there, right? So each of these sections are like modules for these libraries like matplotlib. This pyplot module helps to deal with Python based interface. You can actually use matplotlib to deal with multiple different languages. You can create particular graphs in multiple Java, you can create it in C, you can create it in C++, you can create it in C sharp, you can create it, but for our purpose we want to use for Python itself. So to the module that interacts with Python, helps you build stuff in Python, that is the pyplot module, and we are calling the entire thing as PLT. As a nickname, we are giving it as PLT. Are you guys able to understand this? Please let me know. Are you guys able to understand this, guys? Please let me know. Okay, great, awesome, guys. The next thing that we can do is we are going to get, okay, so now, like I said, matplotlib is a very big module, a very big library. It has multiple different ththings. Similar to that, sklearn is the library that gives you all the tools necessary for you guys to deal with machine learning problems. Okay, sklearn is the library in Python that gives you all the abilities to deal with machine learning problems. But it gives you so many different tools that you don't need all the tools at all points, right? For example, if I am building a sea castle, okay, I'm sitting beside the sea on a beach and I'm trying to create a castle using the sand. Do I need a bulldozer? Do I need an excavation crane itself or something like that? I just need a fucking bucket. That's it. And some water. That is all that I need to create that sand castle itself. Why do I need the entire construction crew to be present right over there, right? So in that particular way, from sklearn as well, we'll only take up those parts that we need while building our project, guys. Okay, so from sklearn, okay, import, we are going to import some proper things from sklearn itself. Pre-processing, we're going to import pre-processing and SVM right over here. Along with that, we are also going to import our from sklearn sklearn dot model selection import train underscore test underscore split split. I hope so I'm not making any particular spelling mistakes, guys. If you guys see any kind of spelling mistakes, do let me know, because I'm really bad at spellings. Okay, from, I'll explain it to you guys. Let me first write the code and then I'll explain it line by line. Up till this point of time, did I not explain you guys line by line everything I'm explaining you guys? Be patient. Okay, be patient, guys. Okay, sklearn learn dot linear underscore model import, and then we are going to have linear regression, linear regression. I hope so that there is no spelling mistakes. Please God, no spelling mistakes. Okay, pre-processing and SVM. Okay, great. Did I make a spelling mistake in pre-processing? pre P-R-O-C-E, P-R-O-C-E-S-S-C-E, P-R-O, I have misplaced an R right over there. P-R-O-C-E-S-S-I-N-G. I think so this is right, right? A-R, linear model. Okay, now I think so everything is right, right? Linear spelling was wrong, pre-processing spelling. That is the reason why I told you guys, like, just look at the spellings while I'm writing the code. Okay, great, guys, awesome. So right over here, guys, let's try to understand what does all these different things mean. sklearn is the library. Okay, sklearn is the library. From that, we are importing two different particular modules directly. Again, if you are importing like this, sklearn and then directly import, then you're importing modules right over there, guys. Okay, the difference between, see, I'm first of all try to understand this. Okay, Yeah, linear regression. Okay, right now it's fine. Okay, so please listen to this very carefully, guys. Okay, the difference between this line of code and this line of code. First of all, you guys need to understand it. When I'm writing import from sklearn, import pre-processing and SVM, I'm importing two big modules directly. Two big modules, like the entire rack of books, I'm importing it right over here. I'm importing the entire rack of books right over here, guys. That is what it means, okay? Whereas if we go on to this particular line of code where I'm writing sklearn.model selection. So first I'm selecting the particular module as well, that okay, from sklearn, that is the library, from the module present inside of it called as model selection, import a particular command, import just one particular book. Here I'm importing a book, one of the functionalities of that particular module. That's it. I'm not importing the entire module. I'm just importing one book from right over there. Are you guys able to guess this? Please let me know. Are you guys able to get this, guys? Please let me know. Yes? Okay. Similar to that, here as well, sklearn.linear model, and from that particular module itself, I'm importing just one particular thing from right over there. Okay, that is the linear regression. Now let's try to understand what is the rest of the stuff. So the pre-processing module of sklearn basically gives you the tools to work with to process the particular data set before using it. What do I mean by that? For example, you get a data set and data is empty right over there. There are some rows where data is missing, some data is wrong right over there. Maybe some data has been just deleted from the data set itself. Some of the rows has been deleted. Some of the particular cells have been deleted from the data set itself. So data is not always clean. Data is not always directly meant to be used. You need to pre-process it. Basically, it means that, okay, when you get milk, right, from cow, it does not happen like, okay, the person just goes and churns out the milk from the cow and just gives it to you. They pre-process it. Okay, they remove the bacteria from that. They kill the germs inside of it. They clean the milk. Then they package and give it to you. In a similar manner, when you are working with machine learning, you cannot use a data set directly. You have to clean it. You have to pre-process it before you are able to use it. That pre-processing, sklearn's module pre-processing will be able to help us out. Okay. The SVM module we might not be using, but it is another algorithm inside of machine learning. Just like linear model or linear regression is one type of algorithm present inside of machine learning, SVM or support vector machines is also another type of machine learning like algorithm that exists. We are going to use some of the tools from inside of it. We are not going to use SVM, but yeah, I've like put it up right over there so that if we need it, we are able to use it at a later point of time. Now let's come to model selection. We have imported a train test split. I don't think so. This is something that I need to explain. Do I need to explain this? Use your IQ. Use your IQ. What would the words train, test, split might actually mean? I want to understand from you guys. Okay, it does not matter. I will tell you guys the right answer as well. But still, I want you guys to relate to what you have learned up till this point of time and implement it right over here. Right? See, some of the stuff inside of machine learning, when you'll be going further, I might not be available with you guys always. So I need to train you guys in such a way that you guys are able to understand code on your terms as well. Okay. So what do you think will this particular functionality do? The train test split, what will it do right over there? Very good, Gaurav Chaudhary. It will divide the data set into training data and testing data. This particular functionality will help us split the data set into the training data and the testing data. Very good, guys. Very good. And again, linear regression, I don't think so it is needing to be explained. It is basically, it will help us get the linear regression algorithm that we are going to use inside of our data set, right? Okay, so we'll run this and it will import all the different things. I hope I'm not getting any errors. Very good. I'm not getting any errors right over here. Now we'll start working with our data set, guys. Okay, so before we are able to do that, let me paste and check. Okay, content slash bottle.csv. Is it working right over here? Okay, I will have to check this up. Okay, so right over here, guys, we are going to create a particular data frame. Okay, we are going to call it as DF. Okay, data frame is basically you converting your data set into a particular format called as data frame using pandas so that you are able to work on top of it. Python cannot directly understand the dataset. The dataset is like an Excel sheet. Python cannot directly understand that. So for Python, pandas provides a particular data structure called as data frames in which it converts that Excel sheet or that CSV sheet into a format called as data frame that looks exactly like Excel sheets but meant for Python. Okay, so that Python is able to understand that. For our current purpose, I'm naming it as DF. Okay, the data frame that we are going to create. We can name it as anything. You can name it as Shaurya as well if you guys want. It is just a variable name to convert a particular like file that we are having, right? We are having the bottle.csv, that is our data set. We want to convert it into a data frame. You can do it by writing pd, that is pandas dot read underscore csv. Read CSV functionality will read your particular data set and will convert it into a data frame. Now here, the data set, as you're able to see, is in the format of read CSV, guys. Okay, it is in the format of read CSV, right? I think so. We'll have to see. Okay, I don't think so. It will take in directly right over there. Current directory Python. Let us check that up. Should I? Let's check it up. Okay, maybe if it works, it works. If it does not work, we'll look into how can we make it work. Okay, for right now, I'm just taking up directly. Okay, this was the path that we had copied from the bottle.csv, right, guys? If you guys remember, we went right over here. Bottle.csv was placed right over here. We right clicked it and then we clicked on copy path. You guys remember it, right? The bottle.csv, I don't think so, has been completely uploaded. It's still getting uploaded right now. How big is this? Like, the fuck, how big is this? Let me check once, guys. I think the download happened pretty quick, right? Let me check up the properties for that. Oh, it is almost 300 MBs large. It is going to take us a bit of time to actually upload it. So we'll not be able to use the dataset. It is actually currently getting uploaded itself. Fuck, how are we going to work right over there then? Shit, it is taking a lot of time to upload. Like till now only half has been uploaded. Maybe if we work on Kaggle, it might be a bit more faster. Let me check it up. Okay. KGGLE Kaggle. This is what we were using. New notebook. Okay. Dishmish datasets. I think so. The dataset is available right over here. Let us check if like this will work. I think so. We will have to shift to Kaggle. We will not be able to use Collab right over here because Collab is taking a lot of time to like upload it. So why is Kaggle faster? Because Kaggle has the datasets already integrated with it, so it does not need to download or upload something like that. As you're able to see that it is already there right over here. Bottle.csv is already there. So let's see, as you're able to see, bottle.csv is already present right over here, so we don't have to do shit about it. So let's take this up. Let's work with Kaggle. Okay, if you guys want to understand how did I do this, let me do it for you guys. Okay, You can just, what you can do is you can just copy this up. I'll just show it to you guys. So how did I do it? Okay, so this was the dataset that we were working upon. Okay, the Coffee dataset Kaggle. I just opened this up. Once I opened it up, I'll just click on this new notebook. Okay, I'll just click on this new notebook, and voila, you will be redirected to a notebook where you can start writing your code. So I'll just copy paste the entire code that I've written up till this point of time into the new notebook right over here. Control V. I will run this. It runs the exact same way as your collab itself. Okay, and we'll copy this as well. Control C, and we'll paste it into the new notebook. Control V. But we'll have to change the path to that. So this will be the current path that we want. So we'll change it up right over here. This is the path that we want to go further with. Kaggle input, calcoffee, bottle.csv. Okay, that is where we want to go further with. Are you guys able to understand what I've done up to this point of time? Please do let me know. Are you guys able to understand what I've done up till this point of time, guys? Please let me know. I made it a little bit bigger so that it is visible for you guys as well. I've not done anything. I've just changed the location of our coding from Collab to Kaggle. Again, Kaggle as well is currently running on the cloud. We are not running anything on our own computer itself, so it's safe and sound. Okay. The next thing that we're going to do is we are going to take out 2 of the columns that we want to work with. We don't want to work with all the columns, right? If I do this, right, we just do df. Okay, run this. I should be able to see the particular data set. Let's see if it is able to run it or not. Okay, so as you're able to see right over here, guys, the particular data set I'm able to see right over here, it is getting printed. Okay, I'm currently printed df. Okay, df is basically your data frame that you have just created. It has all these different columns to it, all these different columns to it, all these different rows to it. We don't want every single one of them, right? There are 8, how many are there? 8,64,863 columns, sorry, rows. 8.5, more than 8.5 lakh rows, and there are 74 columns. There are 74 columns. Do we need that many number of columns, guys? What was our problem statement? What was our problem statement, guys? We wanted to find a correlationship between the salinity and the temperature, right? We don't require that many number of columns right over here, guys. So what we are going to do right now is that we're going to create another data frame. We're going to create another data frame, guys, that is df_bin. Okay, I'm going to call it as df_bin, which will only contain that 2 columns, the data of that 2 columns inside of it. To do that, it is pretty simple. The data frame that we want to take out the 2 columns from is basically df, right? From df, we want to take out 2 different columns. Okay, and then you have to just mention the 2 different columns inside of parenthesis. Okay, that is SALNTY. I hope so that I'm not making a spelling mistake right over here. I will have to check it up. Yeah. So SALNTY. Yeah, I made no spelling mistakes right over there. That is the first particular one that we need. The second one that we need is T degrees Celsius. Let's just copy it from right over here. This is the second one that we need. T degrees Celsius, guys. These are the only 2 things that we need. Are you guys able to understand it? Please let me know. We only need these 2 things right over here, guys. Now, right over here, okay, what we are going to do is that we are going to rename these particular columns. Okay, this does not look nice, like SALNTY. What does that mean? Okay, that's not normal English. T degrees Celsius. What is this? So I want to rename these 2 columns. Okay, if I print df bin right now, right? Df bin. Okay, let's print it out right over here, guys. As you're able to see, you will have 2 columns and all the different rows. As you're able to see, salinity and T degrees Celsius, all the different columns. Okay, 8.5 lakh plus rows and the 2 columns that we want. Now, I don't want these 2 column names, okay, salinity and T degrees Celsius. It looks like 2 badass rappers right over there. So I want to convert it into something else. So convert it into some other particular column name. So to do that, there is a very good way of doing it. dfbin.columns columns. Okay. And I'm going to rename these columns as SAL salinity. I will keep S capital. It looks nice. SAL salinity. And I'm going to rename the second one as TEMP temperature. Okay. So it looks a bit better. Okay, so df bin, that was the data frame that we have created with just 2 columns. I want to rename the columns, so dot columns, that is the property that I'm getting selected right over here, and then I'm just using sal right over here. Why is the print statement not used? Okay, when I'm writing df underscore bin right now, right, it is directly printing out everything. I'm not using the print statement because that just works. Okay, the reason for that is Python sees that, oh, the last particular thing is df bin, it is in my hand, there's nothing else to do with it, so it will just showcase it on your screen. This is a wrong way of doing it. You should definitely write a print statement right over there, but it's fine. I don't mind just like not doing it, just saving a little bit more time. So as you're able to see right over here, the column names have been changed, guys. The column names have been changed to sal and temp, as we are able to see. Are you guys able to understand this? Please let me know. Hello sir, how do I register for a certificate? When I click on the link, it says error 404. Register for a certificate? I'm not able to understand that. If you already have a certificate and you want to validate it, most likely you're going into the wrong particular URL. Do one thing, just email it to support@devtown.in. They will send you the right URL to go to. Okay, the URL has just been changed right now. That is the reason why. Okay. What about dfbin.head? It will just show the first 5 particular numbers. I want all the things, so I'm just doing. Yes, there are multiple ways of printing it. It's not something I'm debating right over here. I just prefer doing this just to check up on things. This is not the final thing, right? Okay, now I just want to see if everything is fine. So this is the wrong way of doing it. The correct way of printing a data frame. Okay, the correct way of printing a data frame is called as .head head. Okay, so this will print the first 5 numbers right over there. Okay, the first 5 rows of your data frame itself. This is the correct way of printing a data frame, guys. What I was doing up till now was just a temporary thing to show you guys that everything is working fine. So if you use dfbin.head, okay, it will print out the first 5 rows in your data frame. If you want the first 20 rows, you just mention 20 inside of the parenthesis. It will open up 20 rows right over there. Okay, it will open up 20 rows right over there. It is taking a second or two. Okay, as you're able to see, 20 rows will be printed right over here. The default mode, if you don't enter anything, is basically 5. The default mode, if you don't enter anything, is 5. So you have got your data set right now. Okay, the 2 columns and everything. We are going to call it as dfbin. So that is what we are using right over here. Now what I want to do is I want to plot the salinity and T degrees Celsius on a screen so that I'm able to see it right over there, and maybe just through visually I'm able to get if there is some correlation or not. Okay, so that is what I want to do. I want to print the salinity and the temperature right over there. Are you guys able to understand it? Please let me know. So do you guys understand what is this error? This is not error, guys. This is called as metadata. This is called as metadata, guys. Okay. You understand what is metadata? You understand what is metadata, guys? Metadata is basically some information about what is getting printed. Okay. Some information about what is getting printed. That is what metadata is. If you don't want to see it, you can just put up a colon right over here. Semicolon right over there. And it should not print the metadata right over there, guys. So let's see. Okay, it is still printing it up. So I think so that is a fault of Kaggle itself. Kaggle just didn't print the rest of the things for me. So that is something that is coming up from Kaggle's end. But usually if something like this is coming up, it will become like a metadata for you guys, some extra information that the platform wants you to have. Okay, in Collab, if something like this is coming up, you just put up a semicolon at the end, it just removes it. I don't know about Kaggle. I've never used Kaggle notebooks. I always use Collab notebooks itself. Okay. How you have opened the Collab notebook? Kyle Menal, I have already told in the class itself, if you are late, then I cannot help you out with the same. You should have been paying attention. I showed the entire way of opening up the notebook in Kaggle, where the dataset is coming in from, everything I have shown right over there. Okay. So let's move on from right over here, guys. So right now I want to create a scatter plot. What is a scatter plot? Basically, you will have the salinity on the x-axis, you'll have the temperature on the y-axis, and you put dots. That okay, if at this particular salinity, we had this particular temperature itself. For this particular salinity, we had this particular temperature. For this particular salinity, we had this particular temperature. So it is like a dot plot, okay, a point plot or a scatter plot. Usually the technical name is scatter plot. I don't know how you guys refer to it. Okay, so let's build that. Okay, so scatter plot, we're going to use SNS, guys. SNS, the best is out there. Dot dot lmplot plot. Then we are going to have on the x-axis, we're going to have the salinity right over there. On the y-axis, what do we need right over here, guys? The y-axis is going to be temp right over here, guys. These are the labels that I'm providing right over here. Okay, so what is the x-axis going to be called as? What is the y-axis going to be called as? You can write the entire thing I don't know what is the spelling of salinity. SALANITY. I hope so that is the spelling. TEMPERATURE, temperature. So this is basically the labels that are there on the x and the y axis, guys. Now we need to provide the stuff with the data as well, right? So the data that we're going to take in is the df underscore bin data set itself. That is the data where the x and y is going to come in. That is df underscore bin. That is where it is going to come in. Okay. So if I try to print it out right now, okay, let's try to print it out right now, guys. Oh, I'm so sorry. There is a problem with this. I think so. There is some error that is coming in. None of Indian. Okay, I cannot change the name right now. Okay, that is the problem with Seaborn. Okay, some of the stuff does not work like your matplotlib itself. I think so that should work. That should not give us any kind of errors. We'll have to use the same particular why double quotations here? Saurav Chaudhary, I've told about strings on the very first day. I'm not going to repeat it. I'm not going to repeat it right over there. I've told about strings on the very first day. Or that is basically a string itself. Okay. I think so it is taking some time to actually read through all the 8 lakh data that is there. It is taking a lot of time, guys. This type of problems usually don't get faced on Collab because I get access to like the best GPU out there, so it's much faster. But again, the data set was way too big to actually upload it right over there. Okay, let's wait for a few more seconds right over here. Okay, so this is what we are able to get from this, guys. Okay, just give me a second. So as you're able to see right over here, guys, the scatter plot that you're able to see is much more accumulated right over here because the points are just so many that it is basically overlapping with each other, but you will be able to get a gist of it, right? At a particular temperature, what are the different particular salinity levels that was there at any particular point of time for a particular salinity, what were the different temperatures that was observed right over there, and so on and so forth. Okay, so this is what we need to predict. I think so the line that we will be getting will be something like this, right? Something like this. This might be the line right over here. Something like this, like just going in the middle right over there of the entire structure. That will be the prediction values that we'll be having at any particular point of time. I think so that would be the point, right? So you guys are able to see that there is some correlation between the salinity and the temperature. As the salinity is increasing, the temperature of the water is also increasing right over there. Are you guys able to see this? As the salinity of the water is increasing, the temperature of the water is also increasing along with the same. Are you guys able to see this? Please let me know. There is some kind of correlation between the temperature and the salinity of the water, guys. There is some kind of correlation between the temperature and the salinity of the water. Let me put in some more things as well. ORD or order is equals to 2, and let us put in CI is equals to none. Let's try to run this up once again. So this is a little bit better representation of our particular data itself. a bit more scattered right over there. So what we were seeing up till here was just till here itself. So I made it a stretch a little bit more so that we are able to see. And instead of having like something like put up the order as 2, so this line that you are able to see, that is a polynomial regression that is going on right over there. We don't require a polynomial regression. We are using a linear regression itself, but just like that, I've just put it up right over here. But as you're able to see, like there is a pretty much great correlationship between the temperature and the salinity. As the salinity is increasing, the temperature of the water is also increasing. Are you guys able to understand this? Please let me know. As the salinity is increasing, the temperature of the water is also increasing right over there, guys. Right? Are you guys able to understand this? Please let me know. Okay. Now there might be a scenario in which the current rows might have some nan numbers. Okay, some numbers that are currently not added. Maybe some numbers are missing inside of the temperature, inside of the salinity, right? There are 8 lakh rows, right? There might be a case in which some of these rows are actually empty. There's no data. Data hasn't been recorded for that particular row itself, for that particular salinity, or for that particular temperature. So what we are going to do is we are going to clean the data set a little bit more. Okay, we are going to clean the data set a little bit more so as to provide it with no nan numbers, no numbers that are missing. Okay, we want all the rows to be filled in its entirety. So for doing that, we're going to use something called, so from the df underscore bin, this is our data set that was there, right? Let's zoom in a bit. df.bin, we're going to use fill na. Fill na basically fills all the particular rows inside of your data set itself. All the rows inside of your data set where there is some missing data. The method inside of which we want to fill it up, method method that we want to fill it up is fill, forward fill basically. What does forward fill basically mean? For example, if the 8th row has missing salinity, okay, if the 8th row has missing salinity inside of it, so salinity will be copied from the previous row. From the 7th row, whatever the salinity was, I'll just copy that right over here. Are you guys able to understand this? Please let me know. For those guys who are asking about attendance, I have not told you guys about something. I would really want to share it with you guys right now. Those students who ask about attendance towards the end of the class without me actually stopping to teach, we note down your email IDs and your names, okay, if it is visible, and we make sure that you guys are not getting your certificates. So if you are not getting a certificate even after attending 7 days, you know why you have not got your certificates. For those who are in the class, for asking questions, for answering questions, they all get these certificates because they were really interested to study. Certificates are only meant for those people who actually study. For those who are just here for attendance, that come in the last 5 minutes of the class and think that they're going to get the attendance and they're going to get certificates as well, that is not going to happen with you guys. I'm very sorry for that. Okay, there's just one particular person, one particular volunteer of ours. He's also a citizen at DevTown itself. He's the one who actually takes down the entire note down of all the different email IDs and all the different profile names for these candidates. We find these inside of the attendance and we just remove it from right over there. So for those who are asking about the attendance, just like Harsha is there shamelessly, right? So these guys don't get any certificates from our end, and they will then come in the next boot camp. Sir, I attended 7 days boot camp, right? And I didn't get my certificates. Like, you don't deserve the certificates. Okay, if you want to pay attention in the class, learn. Okay, get your certificates. If you don't want to learn, please don't disturb the class. Okay, so are you guys able to understand what do you mean by forward fill? Forward fill basically means that if the 8th temperature is missing, then I will copy the temperature from the 7th row and paste it up right over there. I'll copy the temperature from the 7th row and paste it right over there, guys. That is what forward fill basically means, guys. And I want to do it in place. I don't want to create so when you do this, right, if you just write this much, it will create a new data frame for you. It will create a new data frame for you. I don't want that. I want all these changes, all these NAs to be replaced at place. I don't want a new data frame with a replaced NAs itself. I want that only inside of this particular data frame itself. I am replacing all the NAs with proper numbers. Okay, to mention that as well, I'll just write in place. I don't want a new data frame. In the same place, do it. True. Okay, in the same place, do it. Okay, so this should have done it. See the canvas documentation, future warning, fill any method will take blah, 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 blah. Okay, कोई बात नहीं. Okay. Okay, so the next thing that we have replaced all the particular NAs, okay, all the missing data as well right over here. The next thing that we're going to do is we are going to create our model. Okay, we're going to start creating our model, guys. So we'll write the first two particular lines of code first, okay, and then we'll do it from tomorrow onwards. Very less amount of code is remaining. It is going to be very simple. You will be able to understand how easy it is to create a machine learning model. What you will not be able to understand is that how difficult it is to update a model itself. So that is something that when you go into the company, you will be able to understand, right? That is what I'm facing right now. Every month we have to come up with a new model that has better performance, better latency itself. Shit, I hate it so much, but I love to do it. Okay, so let's move on from right over there, guys. So what we're going to do is we're going to create the input way and the output variables that we want for our model first. Okay, so although we have the columns, right, the input column is the sal and the output column is our temperature itself for our model, that is a machine learning model. But we cannot directly feed it in. Okay, we have to convert these columns into NumPy arrays. Okay, into matrices itself. Okay, one-dimensional matrix that contains all the different salinity, one-dimensional matrix that contains all the different temperature itself. So we have to convert this columns into a NumPy array, guys. Okay, in place true is for permanent change, isn't it? Definitely is, because we are changing the same data frame directly itself. That is the reason why. Okay, so to do that, what we're going to do is we're going to create X right over here. X contains np.array array. This is how you convert it into an array, guys. Okay, what do you want to convert into an array? The column that is our salinity column, that is our input, right? So df underscore bin. Okay, from this particular data frame, we want to get the SAL salinity column. I think so. That is the column name that we have given. Let me just check. Yes, SAL is the column name that we have given right over here. And then once we have done this, right, once we have done this, we want it to be of a one-dimensional matrix. Okay, right now if we are converting it, it will look something like this, right, because it's a column, right? It will look something like this. What we want it to look something like this. Are you guys able to understand it? Right now it is vertical. Okay, right now after converting into it an array, okay, that is a vertical array that we have created. What we want is a horizontal array. To do that, the code for doing that is actually pretty simple. Just write reshape, and then inside, why is the autocorrect not working properly? I don't know. Reshape and then -1, 1. As simple as that. That will just make the entire thing horizontal. As simple. That is what we want at the end of the day, right? We want a horizontal particular thing. And the same thing we have to do with the output as well. Just copy paste the exact same thing right over here down below as well. And we'll put it up as a Y. Sir, any tips for remembering the syntax? Make as many projects as possible. Work on as many particular competitions as possible. That is how you start remembering stuff. Otherwise, like, you will just forget. For example, I forgot how to get a dictionary, like how to get the directory pathway inside of Python, right? So I just Googled it up because I have not done that for a very long period of time. So again, that is how you basically remember stuff. And temp reshape -1 1 will basically change your particular arrays from being horizontal in nature, like a column. Right now your arrays are like a column, they are horizontal in nature. What you want is you want it to be vertical in nature. Right now they are vertical in nature, you want it to be horizontal in nature. So reshape -1, 1 will do that for you guys. Okay, are you guys able to understand it? Please let me know. Are you guys able to understand it, guys? Please let me know. Sometimes single quotes, sometimes double quotes. Sometimes I call you Saurav, sometimes I call you Saurav Chaudhary. Is there any difference between the two? No. No, there is no difference. Don't ask dumb questions. Okay? Especially questions that I've already explained in the very first day of the class. Like, you can ask dumb questions at any particular point of time. If I have not explained it to you, that is my job to explain it. But if I've already explained something and you still ask dumb questions related to that particular same thing itself, then you are fucking dumb. You need to improve how to use your brain 101. I suggest this particular book for you. How to use your brain 101. Okay. Solve some particular Rubik's cubes or maybe Sudoku puzzles. I'm shit at both of them as well, but yeah, you can definitely try to do that. Okay. improve your brain capacity, man. I've already taught it on the very first day. You keep asking it on the, I don't know, fifth day. If you have a particular memory span of 5 days and you just forget everything, I think so you need to prepare notes right over there. Okay. So forward fill not clear. Okay. I'm standing in a line. Okay. There are some particular, okay. Many of you guys are not able to understand forward fill. Let us try to understand it. Where's my pen? Okay. So right over here, let's see that there are some people standing in a particular queue. Okay. These are all the people that are there. There is some space, then there is again a person, then again a person, and again some space, then there is again a person, then there is again a person. Okay. Each of these people will be named as something. So I'll name it as A, B, C, D, E, F, G. So these are two empty spaces right over here. When I apply forward fill, right, what will happen is from the previous person, I will make a copy of that previous person and will put it up right over here. So there will be a C right over here. It was empty. Originally it was empty. But now there I will just copy whatever was there in front of here. I'll just copy and paste it right over here. So that this is empty. I'll just copy paste this right over here. So this will be E right over here. That is what forward fill is. FFFILL. Okay, forward fill. Okay, that is what forward fill basically is. I hope so that you guys are able to understand this. Please let me know. Now, even after doing forward fill, there might be a condition in which there were two particular empty positions. Instead of having just one empty position right over here, there were two particular empty positions right over here, guys. In that particular case, what happens is that you copy one of them right over here. So this will be B. Okay, B will be present right over here. But this still remains empty. This will remain empty because originally there was nothing right over here. So this still remains empty right over here. So you want to drop the rows that contains these type of empty spaces. We don't want that. We have filled most of them. We have filled most of the empty spaces right over here, guys. As you're able to see, we have filled most of the empty spaces, but there will be still some rows inside of which there will be still some empty spaces present. We don't want to keep these empty spaces, guys. We don't want to keep these empty spaces. So we'll drop them off. We'll remove those particular rows itself. Doing that is actually pretty simple. df underscore bin. Okay, that was our data frame that we are using right over here. Does FFFill work in SQL? There is a particular module for that as well. Yes, definitely it works in SQL, but not directly. Of course, there will be a separate module in SQL that you'll have to use. Okay, so df bin dot, and I'm going to use NA, drop NA, drop drop, and then NA. And this also I want to do it in place is equals to true. So this will drop all the rows that still contain any kind of NA values, any kind of empty values itself. It will do that for us. Are you guys able to understand everything up till this point of time, guys? Please let me know. Is there something backward fill? Yes, there is a B fill as well that exists. That is backward fill. That is the exact opposite. You like copy whatever is next. That is backward fill right over here. Okay, the next thing that we want to do is we want to split our data set into training and testing. Okay, doing that is actually pretty simple. X underscore train train. Okay, then you are having X underscore test test. Then you're having Y underscore train train, and then you are having your Y underscore test test. Right, these are the four things that we need. Okay, training set. Okay, training X and training Y. And then testing set, testing S and testing Y. Are you guys able to understand it? Please let me know. Should we do drop NA before NP array? Yeah, I can do that. Okay, there's no issues in that. I just remembered it right now, so I did it. Okay, so you can definitely do it before creating it into an NP array as well. But I did it right over here because that is separately. You have to do it separately using pandas. But I did it right over here because I remembered it after writing the NumPy arrays itself. I remembered that, oh shit, I have not done it. Okay, so right over here, guys, I think so this is not something that I need to explain that what is X train and what is X test. Like the X, that is the input of training set, and the input of testing set, the output of training set and the output of testing set itself. I don't think so that is a big deal right over here. And that would be equal to do that, we have already going to directly use train test split. I'm just going to copy paste it. I don't want to write it once again. It is a very big line. Control C right over here, and I'll paste it right over here. Control V, and we have to split the X comma Y right over there, and test underscore size. So I'll keep 25% right over there. Okay, test underscore size is equals to 0.25. That is 25%. So 25% of the entire data set, 25% of the entire data set will be stored as the testing data set, and the rest of the 75% will be stored as the training data set. Here x and y are basically the numpy arrays that we have created right over here, right? The numpy arrays, salary and sorry, not salary, the salinity and the temperature, and the test size is basically the size of the testing data, that is 25% right over here. Okay, and that gets allocated right over here directly, so we don't have to do shit right over there. Okay, so let's move on to the next particular aspect of this, guys. The next particular aspect that we are having right over here is that the REGR regressor. That is our model, guys. We can call it as model as well. This is a short name, MODEL model. Okay, model. You can call it as anything. You can call it as Shaurya as well. You are basically creating the model. Creating the model is simple. Okay, LINEAR linear regression. REGRESSION regression. I hope so the spelling is correct this time. And now we are going to wait till tomorrow's class to create our model itself. Okay, we have created the dataset, we have cleaned the dataset. We're going to create our model tomorrow, and we are going to see how well it is able to work or how shit it is able to work. Most likely it is going to be shit, because this dataset is not meant for a linear regression algorithm. It is meant for a polynomial regression algorithm itself. It will look something like this. But yeah, we are using linear regression, so it's fine. Okay, we'll understand. This will be a benchmark thing itself. Okay. So let's start with the attendance right now, right? Otherwise, you guys will eat my head off. So let's give you guys the attendance right now. Guys, again, today, many of you guys came late in today's class. Okay. Please don't do this. Be early in the class itself. Otherwise, if you miss on the attendance, you guys will miss on the... I will not be able to help you guys after that. Don't come complaining to me that, sir, मैंने last day तक attend किया. I am not able to get the attendance right now. See, attendance is only given to those people who are serious about their studies. I am able to understand today was the IPL match between Rajasthan Royals and like your RCB itself. That is the reason I gave the attendance today a little bit late. But from tomorrow onwards, tomorrow is no match, nothing. I want you guys to be on time in the class. Is that clear with everybody, guys? Is that clear with everybody? Please let me know. Is that clear with everybody, guys? Please let me know. Great. So right over here, guys, the attendance is there in the live chat. Will be kept open till 9:33. After 9:33, the attendance link will be closed. After 9:33, the attendance link will be closed, guys. Please start filling up your attendance right now. At exactly 9:33, the attendance link will be closed. Please start filling up the attendance right now. The attendance link is in the live chat. We'll meet in our tomorrow's class and we'll continue from right over there. Thank you so much, guys. Exactly at 9:33, the attendance link will be closed, guys. Please start filling up the attendance right now. Okay. Okay. Bye-bye, guys. Bye-bye.